Okay, thank you. Okay. Okay. To include this issue, I will necessary some concepts about invasion, like what is the alien species and invasive species. One invasive species is an alien species that can cause economical or environment harm. The big question and the necessity of study and understand what happens when we have one invasion is the economical impact that these species can cause. Okay, there exists a big process that happens when we have an invasion, but we are interested in this question. Well, how does dispersal mode or reproductive system affect the spread? This is the most question in this work. And to how starting point, we can work with the diffusion equation and in special understand how the diffusive term makes. But there exists a situation in which this equation don't work, like when you have parental care or hunting strategies. In this situation, it's necessary to introduce another term or another form to work. Like, for example, we can introduce high-order terms, and when you use these terms, you can see that there is this we can consider the retention effect. There exists some research about this, made for Bevilacqua and Gallion, and in his work, he's talking about how you can introduce high-order terms in diffusion equation to explain how makes the retention in biological invasion. And this work is introducing a big question because there exists a lot of works, and these works, I will return you on. Usually, the works about the use of high-order terms in diffusion equation, considering this like a black box. It is used because it makes well in the correct simulation, and it fits well the database. In works in paper of Bevilacqua and Gallion, they explain or give an interpretation for these terms, and for this they illustrate and connect the round walk with a classical diffusion equation. And in this work, they explain the governating rule, considering that fraction alpha is retained in one cell, and another part, the setting volume, 1 minus alpha is transferred to the neighbor cells in each time step. And this results in this equation in which we can see this term that can be considered like the effects of retention in the process. And to introduce this situation, we use this initial condition and boundary condition, and we simulate this model. Okay, we start with the check, the expected effect of retention, and you can see that when retention is in the process, the diffusion is have a speed, has a reduction of speed. And what happened when this beta parameters is introduced in this equation? Well, when we have the analysis of coefficients, we can see that although the term associated to diffusion has a logistic behavior, and U maximum is in 0.25, but when you see the diffusion process, I don't know if it's possible to see, but we can see that the stronger retention effects don't correspond to this value, beta. We try to understand this process and see that there exists an imbalance between the diffusion and the retention in the equation. And the higher retention makes when you have 75% of diffusion is represented by the retention. So the higher retention works in when beta is 0.25. If we want works and understands better how retention can simulate diffusion, and especially when we work with invasion, we should understand how species can interact. And the most common model to this, is the lógica Volterra. And this is good because we understand well what is the dynamic, and we can integrate it to the model. Okay, and so what we have here, the diffusion retention model with the high order term, and we can see how these species interact, the prey and predator, and if we have retention and one on another species, and we can see until if this has an impact in the process of invasion. And we consider this boundary condition. This one is the initial condition to the predator, and the another one to prey. And to this study, we consider two situations. One in which we don't consider rotation in any species, and another in which only the predator species has rotation. And this work is about invasion, so we consider that the predator is to an exotic species. And in both situations, we can see here is prey. In green is the prey represents prey, and red represents predator. And here is the expected situation, and we can see here when we have retention, we can see that the prey is more consumed by the predator, because there's existing process, the rotation. The predator don't, the front that represent the predator don't invade the local, the habitat too fast. So, and to understand better this situation, we can see that although the inclusion of diffusion maintains the basic characteristic of Lotka-Volterra system, we can see here, the inclusion of diffusion in Lotka-Volterra model alters the regularity of the limit cycle. But because there exists a diffusion, so there exists a little difference here. But when we have diffusion in process, we can see that the retention, we can see that the process, the retention, depend of diffusion effect. So this means that the predator, the density of predator is not too high that we have only diffusion. And in this simulation, I think that is the result most important is that to a biological situation is that when you have retention, for the same density of predator, is this one, when we have retention, is this one, a larger number of prey persists. So here, when you have, so if we consider that invasion species happy because economical interest is worse when this species, the invader, has retention in his process of diffusion. Because you can see we can see a situation in which the native species goes to the limit in the don't persist. And when we compare with retention, the situation with retention or without retention, we can see some situation like when an environment is invaded by an invasive species, and these invasive species exhibits retention, have a great chance of, the prey have a great chance of survival because they can maintain themselves and higher population level compared to the situation which invaded those no needs a minimal population to maintain. And so when you can choose one species to introduce in the habitat, you should consider if this species has this comportment. And okay, after this, we can bypass to another situation and consider the real biological impact of invasive species. And you can see that there exists many models of in which the impact of the economical impact is considered. But this model usually don't consider the retention in his survey. So we propose one model in which we consider two distinguished species. One is the invader and another is the resident species. We consider that these two species interact, and these interacts can be competition, diffusion, and one diffusion that one species imply the diffusion in one species implying a diffusion in the diffusion and another species, for example. But in this model proposed, we consider that only resident species is economically valuable. Well, is necessary that the impact on the invaders depend of interspecific interaction. The first model that we consider was proposed by Barbier, and in his model, there exists one situation before, and we analyze this situation after the invasion. For this, it is necessary to consider the profit from the exploiting the resident species. And to exploit, we consider that the native species is harvesting, and the harvesting function is affected positively for to stock and E-force. And another hypothesis is that there exists diffusion, there exists growth function, and we consider that this species is here, and these species interact one with another. And the bioeconomical modeling proposed is this one, and this is the function that represents the harvesting. This F1 and F2 is the function to represent the interaction between these species, and is a problem. This problem considering optimization from the harvesting of species. But how a starting point, we can consider in this, to compare, this is the model proposed by Barbier too, and Shizezad. We proposed that we include in this model this term that could represent the retention in the diffusion equation in each one equation. And this is the new model to the competition and the harvesting of invader species. To work with this model, it is necessary that you use model to represent the pre-invasion situation. And in this situation, we consider that PA could represent the situation before the invasion. It is necessary to solve this correctly, this model. It is necessary a lot of information about these species, like what is the function that could best represent the harvesting, or one better function to represent the interaction between these species. And to conclude, we are still working with this equation, and because of we have a lot of questions in this problem, like how we can handle with the optimization problem in a situation in which the interaction between these species and we don't have unscale between the value to the before the profit before invasion and after invasion, whose we can use in this equation. And how I am in Amazonia, we are interested for species to use it in this model. So, thank you for your attention.